This is unit number 4, video number 5, double replacement reactions. Talk about double replacement reactions, we're really talking about reactions between strong electrolytes. So these are compounds, they hit water, they form ions. That's what you really want to have in your head. Hit water, form ions. Then those ions begin to collide. And as they collide, the question we're asking is a precipitate formed? That would show up as a cloudiness in the water, eventually settling out. Solubility rules you should have a list of. You have a full list. I'm not going to draw a full list up here. Just highlight a few things. Nitrates and alkali metals. These ions in compounds make the compounds always soluble. So any compound involving a nitrate, which is NO3 minus 1, or an alkali metal, sodium plus, K plus, all that, those are going to be soluble in water always. Sulfates, SO4 negative 2, those are usually soluble. So I've got up here sometimes. Chloride, bromide, and iodide, a very important class of compounds because they're so abundant. Those are going to be usually soluble, a few exceptions, typically lead, silver, mercury, and then sulfates, a couple others. Carbonates, hydroxide, phosphates, you may have some others in your list. These three are usually insoluble. The exception would be alkali metals and ammonium ion. I don't have ammonium ion up there, but that would be a common exception. Okay, so let's write out some double replacement reactions. Let's say we have sodium chloride, and we're going to react it with lead 2 nitrate. And we want to know what's going to happen. Well, sodium chloride containing sodium metal is going to be soluble in water, so that is aqueous. Lead 2 nitrate containing nitrate, that's going to be soluble in water. So let's look at what's happening in our beaker. So here's our beaker, and we drop these ions in. If we drop these ions in, we're going to get not sodium chloride, but sodium ion and chloride ion. They're separate from each other at this point. That's what being a strong electrolyte is all about. Then we're going to have lead ion, lead 2, Pb plus 2, and nitrate. Okay? Those are floating around. So these are floating around, and lost my color here. Let's go back to the black here. Colliding with each other. Like charges, so the chloride and nitrate, when they collide, they're going to repel because they're both negatively charged. The sodium and the lead, when they collide, they're going to repel because they're similar charge. So it's going to be the opposite charges are going to attract. Sodium is going to collide with nitrate. When it does, because nitrates are always soluble, it'll stick, but water will pull it right back apart. So water has the ability to pull that apart. But when lead strikes a chloride, now it's going to stick, and since that's one of our insoluble compounds, water is not able to pull that back apart. We've made a new substance at that point. So over here, we're going to write our resulting compounds, which would be sodium nitrate, but because both of these are always soluble, that's aqueous, and we're going to make lead 2 chloride, PbCl2, but that is a solid. So we have solid lead 2 chloride. Obviously, we're going to go through and balance that, put a 2 there and a 2 there. So in double replacement reactions, we have collisions between ions that may create a new substance. If it creates a new substance, it's not easily dissolved right back into the liquid, in this case water, then we have a reaction that's occurred.